Salam Sejahtera. Today we are going to present about our presentation that is mesh analysis and mesh analysis with current source. Before that, I will introduce my group member, that is me, Joanna Delon, member matrix B082110062.
Hello, my name is Muhammad Adib bin Nordin. My matrix number is B082110265.
My name is Michelle Yakfrilin. My matrix number is B02110210. In this video, we're going to explain what and how mesh analysis and mesh analysis with current source is used to solve an electrical circuit. First of all, we need to know what is mesh analysis. Mesh analysis is a method used to solve a circuit to find the current and voltage value by assigning mesh current in the essential meshes or independent meshes. There are few steps taken to apply mesh analysis. First, we need to label the circulating current as I1, I2 depending on the number of internal loops it has. Next, Kirchhoff voltage law is applied in each loop in terms of current and resistance. And finally, we solve the equation that we had found simultaneously to find the value of voltage and current. Next, we need to know what is mesh analysis with current source. Mesh analysis with current source is a method used to analyze a complex circuit where two meshes have the same current source. This method is also known as super mesh. In order to apply this method, first we need to form an equation of mesh, which is not a super mesh. Next, a current equation is formed from the current source present between two meshes. Then, an equation of Kirchhoff voltage law is written for super mesh by not considering the branch of the circuit that contains the current source. Finally, those equations are solved simultaneously to find the mesh current value.
So this is an example for circuit mesh analysis. To identify the mesh analysis circuit, there is no current source in the circuit. That means that this circuit is a mesh analysis. In this circuit, it shows that there have two voltage source, that is 10 volt and 20 volt. And then there is three resistor, that is R1 10 ohm, R2 20 ohm, and R3 40 ohm. In this circuit, there is two loops, that is loop 1 and loop 2. To solve this problem, first step that is to find the equation for current loop 1 and current loop 2 using KVL, that is Kirchhoff voltage law. For equation loop 1, current loop 1, that is V1 equal to VR1 plus VR3. V1 is 10 and VR1 is 10 I1 plus VR3, that is 40 times by I1 minus I2. The answer will be 10 is equal to 50 I1 minus 40 I2. This equation will represent equation 1. Next, we need to find equation for current loop 2. That is equal to negative V2 equal to VR2 plus VR3. Negative V2 is equal to negative 20 volt equals to VR2, that is 20 I2 plus VR3 is equal to 40 times by I2 minus I1. So the answer for this equation is negative 20 is equal to 60 I2 minus 40 I1. This represents equation number 2. Next, we need to substitute the equation. Before we substitute the equation, we need to simplify the equation number 1. That is 10 equal to 50 I1 minus by 40 I2. Simplify the equation and then the answer will be I1 equal to 1 plus 4I2 divided by 5. This represents equation number 3. After that, we need to substitute equation number 3 into equation number 2. So the equation will be negative 20 is equal to 60 I2 minus by 40 times by 1 plus 4 I2 per divide by 5. So here the answer will be negative 0.5 ampere for current 2. After that, we need to substitute I2 into equation 3. It will be I1 is equal to 1 plus 4I2 divided by 5. The I2 will be negative 0.5 and the answer for current 1 is negative 0.2 ampere. Lastly, the answer for current 1 is negative 0.2 ampere and for current 2 is negative 0.5 ampere.
Alright, we will solve the super mesh example question. Okay, how to solve that example question? Okay, first we need to see the circuit is super mesh or not. Okay, we can see that the circuit have two mesh that have same current source, so it is super mesh. So we use super mesh analysis to solve this example question. We redraw the circuit using super mesh analysis. Then we identify the current for each resistor. We can see that here I2 is equal to ID is equal to I2 plus I minus I3. Why? Because the current flow of ID and I2 is same, but I3 is opposite direction of I2 and I2 and ID. So we need to minus I3 to get the ID. Then we can I3 is equal to negative 2A. Why? Because the current source of I3 is opposite direction of the from the current source of I3. Then we apply KVL equation. We can get the equation given like in the slide. Then we solve it. When we solve it, we will get I2 is equal to negative 0.5A. Okay. How about I1? Okay, we can see at the information that we write, I1 is equal to 1.5 plus I2. So I1 is equal to 1.5A minus 0.5A. So I1 is equal to 1 ampere. So that's all.
So that's all from our group that represent mesh analysis and mesh analysis with current source.